13 of Q Division hereby present our Engineering Exploration Course project. Among the 4 need statements, our need statement was the winding machine, and we chose copper as the suitable material to be wound. Our team members are Raghavendra, Rohan, Sejal and Shweta. We've done this entire project under the guidance of Madam Padmaja. This process is done on the principles of the engineering design process. It has 5 steps. First one is the problem definition, second one the conceptual design, third one product architecture, fourth one is virtual implementation, fifth one is design communication. So when we focus on the problem definition, it states that to design a thin copper semi-automatic winding machine which performs the work accurately, which is cost effective, safe, user friendly and portable. It should not exceed the size of 4 into 5 feet, should be able to wind a wire of at least 1 meter per minute, budget to build should not exceed ₹4,000 and machine should work for a duration of 45 minutes continuously. It should take a number of turns from the user and terminate automatically after the winding is complete. Machine should indicate to the user after the winding process is completed. Next we have the function tree and function cluster. Function tree. We have 4 main functions, that is handling copper, handling spool, indications and casing. Under handling copper we have hold the wire, sense the wire and store the wire. Under handling spool we have hold the spool, sense the spool and rotate the spool. Under indications we have the on and off indications to initiate the winding and then terminate the winding. On casing is how we case the machine. Subsystems we have 3, that is wire holding unit, wire winding unit and wire cutting unit. So based on our function tree and our problem definition, we have designed 4 conceptual designs. The first one here is we are using a copper reel, and then from the reel onto the pulleys the wire is sent and it's wound on a cylindrical spool here. Here we are using a DC motor for the movement of the wire and a stand. In the second conceptual design, we have a rectangular spool, and with the help of the wheels and a bobbin reel, we are able to send the copper wire onto the rectangular spool. Here also we are using the DC motor and the stand. In the third concept, we have the wheels as the spools and a cylindrical reel where the copper wire is sent from the resin onto the wheels. Here also we use the motors and sensors. In the fourth conceptual design, we have a prismatic spool where from the bobbin reel we have the copper wire sent onto the DC motor from the stand to the spool. So these are our 4 concepts. Among the 4 concepts, we had to choose the best one, and with the help of the puck chart, we've chosen the first concept to be the ideal one. And the parameters we've included in the puck chart was the machine to be semi-automatic, user-friendly, safety of the machine, portability of the machine, and the weight of the machine. So our selected concept was the one with the cylindrical spool, the pulleys, the DC motor and the copper wire reel. Next one we have the virtual implementation. Here is the video.
Now I am going to tell about our 3D model. This is the base of our 3D model. Blade used in cutting mechanism, DC motor, empty spool, bent stand grip for holding the spool horizontally, 2 servo motors, wire storing spool, spool holder. This is our final 3D model of copper winding machine. Mainly 3 subsystems are present: wire holding unit, wire winding unit, wire cutting unit. Working. The wire from storing spool is pulled and tied to a winding spool. Now system is ready to wind. Through rotatory encoder, number of turns should be set. Then switch the push button which runs DC motor, servo motor and starts winding. After completion, the servo motor connected with blade will cut the wire.
Next, we have the 3D model of our entire system. This is the side view and the next one is the top view. We have the bobbin type reel from which the copper wire is wound onto the stand through the DC motor and then wound across the cylindrical spool. Next, we have the circuit diagram of the entire system. It consists of the DC motor, rotatory encoder, breadboard, photoelectric speed sensor, LED display, Arduino Mega and the servo motors. So the flow chart of our entire system. First, we initiate the start and then it senses the wire, then the motor is on. After the motor is on, the servo motor 1 is on and the winding starts. Simultaneously, the DC motor is on and the spool turns. Then the number of turns is counted, then switch on to servo motor 2, cutting mechanism and then end of the mechanism. Next, we have the bill of materials. So for this, we are totally using 16 items. First one is the base made up of foam sheet, which is 30 into 15 centimeters, 1 centimeter thickness. A reel of plastics, 5 centimeter length, 6 centimeter diameter. Spool of plastic, 15 centimeter length, 8 centimeter diameter. Blades of steel, 1 centimeter wide, 0.7 mm thickness, 2.3 centimeter length. Rubber bands, small. DC generated motor, 12 volts, 60 revolution per minute. Gears, 1 centimeter diameter. Thread guide made of acrylic sheet, 17 centimeters. Servo motor, 180 degree. Microcontroller Arduino Mega 802560. Sensor, photoelectric speed sensor, outer diameter 22 meter. Bore diameter 3.5 mm and 0.35 mm thickness. Display, LED display 0.96 inches. Nuts 0.4 centimeter. Bolts 0.41 centimeters. Holders acrylic sheet 12 centimeters and then the LED lights. Next, we have the motor sizing and battery sizing of the entire system. So first we need to calculate the torque on the DC motor, which is 1.23 Newton centimeter. And the safety factor is 1.5. So the speed of the motor should be 60 revolutions per minute. And then we have the torque on the servo motor, which is 9.4 kg centimeter. The speed should be 65 to 70 revolutions per minute. And the maximum current drawn by the DC motor is 300 milliamperes. The maximum current drawn by the servo motor is 200 milliamperes. So the total current is calculated by current drawn into running time into number of motors. So the total current is 2.1 ampere hour. Next, we have the entire function specifications. So our functions are placing the spool, indication of the starting process, drag the copper wire, winding around the external spool, linear motion of the wire, indication of the ending process, cutting of the wire. So the respective specifications are: after the spool is placed, it should be vertical to the base. Then indication of the process is done when the LED blinks for a few seconds. And then through the help of the DC motor placed externally, it has helped to drag the copper wire with the help of the pulley. Then winding around the external spool, it should wind around 1 meter copper wire linearly. Linear motion, the article used of linear motion should be perpendicular to the base. Then the LED again blinks for the termination of the process. Then cutting of the wire is done manually. So this 3D model, which is already shown before. Next, we have our virtual simulation.
This is the virtual simulation diagram of our project. So here we have used Arduino Uno, DC motor, 2 servo motors, 1 breadboard and 3 push buttons. So then let's go for the code. So here is the code of a project, which is completely based on C programming. So next, with the simulation. The first push button is used for taking the input turns. So let's take input of 3 or 4. And the next second push button is used for running the DC motor as well as a servo motor. So here you can see DC motor starts rotating and a servo motor. So after completion of the number of inputs given, the third push button is used for cutting mechanism. After pressing this servo motor cuts the remaining copper thin wire.
So that was our virtual simulation. Next, the overall documentation done so far is on the GitHub, where we had 7 steps, that is gather pertinent information, problem definition, conceptual design, virtual implementation, functional specification, interface performance specification, and the code. So the software used during our process were the Autodesk Inventor for 3D diagrams, Tinkercad for circuit modulation and simulation, Circuit.io for building and our circuits, then Draw.io for drawing flow charts. Thank you.